Hi, in this video I'm going to do reverse engineering and 3D print of an EV battery shield. I have already made the 3D scan in my previous video using the Creality Simul S1. So in this chapter I will focus on reversing with the Autodesk Inventor. In a collision, I think this corner will take the impact, not the bottom or the front, because in the bottom, the tire is going to protect it because the tire is way lower than this. So there's a chance when the pedal is collapsed, this corner will hit the rocks or the gravel and dent the battery packs and cause the fire. Okay, here's in the Autodesk Inventor, and this is the point cloud from the 3D scan Simul S1. I'm going to create a part on a YZ plane, so I'm going to crop, make a thin section here. Next, I'm going to create a component, battery cover on the YZ plane, and I'm going to trace a line. This part is made with the synthetic rubber. It's not going to give a 90 degrees wall. So this is how I usually do. I will draw a line longer than it has to be. One more here. So I can use this to control the position. So this line is fairly thin, 5-6 microns thickness. So now I'm going to add arc. Next, I'm going to extrude it in two directions. Top one we go up to here, and the bottom one we go all the way down to the bottom. Let me change the color to the clear color. Next, I'm going to cut this chamfer. I'm going to create a sketch on this plane. F7, project cut edge. And then I'm going to cut a chamfer here, approximation. So it will look like the original shape. Let me see. I'm gonna use this profile for cutting on both directions. Okay, now it's cut. Next, I'm going to create a hollow shell. When it's in the collision, the bumper should be able to collapse to absorb the impact. So I'm going to print it with a thin wall. But for the FDM printer, I'm going to use 2.4mm for the wall thickness. So I'm going to use a shell command, a wall thickness, and I'm going to remove the top here. Okay, now we have a now you have a shell 2.4. Sorry, it's 2.4, not 2. Okay, I think this wall is a bit too tall. Create a sketch here to lower it. Line from here to here. Going to cut it about this. 0.75mm. Okay, now it should be in the correct position. Next, I'm going to create this wall here, all the way from here to here. Crop the point cloud just for this area. Next, I'm going to sketch, project geometry, add the line here. Okay, and then the wall will go to here. At this point, going to add the line here. Okay, so I'm going to extrude it until it reaches the top here. Okay, so now it's extruded. And next I'm going to cut this edge here. E for cutting. Okay, now it's taking shape. Okay, next I'm going to create this wall here. Make a sketch, project geometry. So I'm going to draw a line here and another line here. Okay, let's extrude this. Yeah, 4mm for the wall thickness. Okay, you can see that there are 3 ribs here that in contact with the battery case, but the lip thickness is only 1.2mm, which is too thin. I'm not going to make the thin lips like this for 3D printing. I'm going to project the line here, offset it because it's a little bit shorter. See here? I'm going to end it here extend it. Okay, so this is what I'm going to extrude it. Let's make some fillet, small one, 0.4, let's see. Okay, 0.4 look great, looks okay, 0.4. So I'm going to extrude it from here to this plane. Next I'm going to cut the groove here. So I'm going to create a sketch here, project geometry. I'm not going to do a slice of the point cloud, just simple do this. And then I'm going to cut it all the way out here. Looks okay now. Let me do another cut here. It's a chamfer cut, project geometry. It's a chamfer cut. I'll just do like this, not exactly match because I need to start from this corner. I'll stop just right here. This will be the contact for the battery case. Okay, this is how it looks. And I missed one of the wall here, so I'm going to fill it. Extrude to this face. Okay, now the wall is filled. So I'm not going to add the stiffener here yet because I want the wall to collapse upon impact. So I will run a simulation later to see if I require the stiffener here. But let's add some chamfer around the edges. Let me fillet it. Okay, let's fillet the sharp edge. I think I need to fillet this one as well. 7. Okay, next I'm going to create a hole mounting, a box clop it. So I'm going to create a sketch on this plane. This is how I find the center of the hole. I use a 3-point arc. The point cloud from the Samon S1 is very thin. It's extremely thin. Thinner is the better. Next I'm going to create a hole. I think I'm gonna use 12.5 millimeter for the diameter. I'm gonna remove this arc. Okay. Next I'm going to draw a line, horizontal line. Draw a circle. 12.5. Lock the line. And I'm going to move the circle to align with the point clouds. Uncrop the point cloud, extrude it until it reaches the top. Yeah, I think it's the same height, so it's gonna reach the top of this wall. It's flush with this wall. Click on OK. Next, I'm going to extrude it down to the bottom of the shell. Sketch, cut edge, F7. So I'm going to pull it down until it's extend beyond the wall here. I need to make a second extrusion. F7, extrude one more time. This time I'm going to go just about this. Okay, now it's filled all the way to the bottom. Half section wheel. There's a gap here. Create one more sketch. Cut edge, F7, extrude. So I need to make 3 extrusion. Wheel, half section wheel. Okay, now it's totally filled in. Okay, next I'm going to create a hole opening. I think this one is a flat plane. So I'm going to project so that I can find the center of the hole. Create a circle. So it's not in the center because the material is made from the synthetic rubber. So it's deformed after they remove from the injection mold. Because they have a stiffener, it shrinks and it pulls the cylinder toward the wall. So I need to find a diameter of this opening. So I create the arc here. It's 4.6 millimeter radius. So it's 9.2 for diameter. Same for here. This one is highly deformed. The hole, the inner wall of the hole, because of the injection mold. So I can produce this part more precise with the FDM printer. I'm going to cut this to here, 34. So with the S1 I can see the depth of this hole, so that I don't need to use the vernier caliper for the whole process to reverse this part. Okay, let's add the hole here. It's M5, so 5.5 would be good number. Yeah, the original hole is also 5.5. I need to make a fillet here, 1.2. Okay, so I'm not going to add the stiffener yet. Let's see if I can. Let's see how much this bumper can hold. I put it into a simulation. Okay, stress analysis, create study. And for the materials, I'm going to choose, I don't have PETG, so I choose PET for the materials. And I'm going to add the frictionless to this wall and this wall. That will be the contact point on the battery casing. And I'm going to add the fix on this two faces, fix support. Click on OK. When it in collision, it's going to hit either on this face or this face, but not both at the same time. So I will simulate this face first. I need to add something for the load to be applied on. Create a small circle, extrude it to a very thin 0.2 millimeter, and this one also, small circle, extrude for 0.2 millimeter. I'm going to add the force. Let's try 50 kilograms, 500 newtons. Simulate run. Okay, so it's deformed. So it will deform about 1 millimeter. From this wall to this wall we have a 7 millimeter, and from this wall to the edge of the cylinder we have about 5 millimeter. So 124 megapascal. This plastic, the PETG will break. So PETG will break at 42 megapascal. So this is the green color is 49 to 74, so it is going to break at 50 kilograms. So I need to add some fillet here. I think it's going to help. Extrude it to the bottom. So I add this, run the simulation again. Yeah, it's better. It reduced from 70 to 59, but it still breaks. Maybe I need to add the stiffener. So the original designer is correct. This part requires stiffener. Create a sketch here, cut it, and I'm going to add like a stiffener here because it's FDM printer. The wall thickness should be 2.4 millimeter. I think that should be better. Original one is too thin. I'm going to extrude it to the bottom. Going to add it here, 2.4, and this one also, and 2.4, align with the hole center. This one, okay, let's simulate one more time. Okay, so it's only 15 megapascal. We increase the load to 100 kilograms, 1000 newton. So it's still under 40 megapascal. So it can carry point load more than 100 kilograms. Okay, let's put the load in here. Let's put it in 100 kilograms, 100 newtons. Simulate run. Okay, so it's overstressed. You can see here it's overstressed, 112 megapascal. So the bottom part here, it cannot protect from the point load more than 100 kilograms. Let's see how much it can carry. Let's try 40 kilograms. Yeah, it's pretty close at 40 kilograms, 45 megapascal, but the stiffener walls will be collapse. For the front bumper, 100 kilograms point load is okay. For the bottom, it's only 40 kilograms of the point load. Okay, before send it out for printing, let's do a cross section check. if anything is all there. So it can only protect at the front here. The bottom is not going to be protected by this bumper. I'm going to just drag and drop the step files here. Okay, and I need to print in the with 100% in fill. So it's gonna take 1 hour for one piece. Clone it for one pieces and mirror it so that I can use on both sides. 35 grams for each bumper. Send it to the printer. So I'm going to print this with the transparent PTG. Okay, let's check the print quality. It fits perfectly. Yeah, I like the color. I think it's look better than the black rubber. So in the next project, I'm going to change this into this as well. Going to reverse this. This one is already from my previous project. A protector for the bracket. So it has a license edge here that will protect the battery cover on the side. Okay, this will be the cutout for the screw that mount here. They have a screw here. This will be the cutout for this screw on this side.